in one of the areas that we see VI Grade really expanding into, and that is the application of simulators into the ADAS space. So we're really lucky to have him. Please come to the stage, Mr. Greg Stevens.
Thanks. So a number of affiliations to get out of the way first. So I spent 34 years at Ford Motor Company, 20 years in vehicle dynamics. So I got to climb that same sort of skepticism curve that Murray talked about relative to simulators and really saw what was possible. And then I moved over to ADAS, spent 14 years in ADAS, and I retired last December as a chief engineer of ADAS features. And I believe ADAS is on that same journey from skepticism to believer. I think it's still earlier days on the ADAS side. By ADAS, I mean advanced driver assist systems, specifically levels 0 through 3. But I think the same way we saw just sort of the consistent engineering pressure of people finding problems, solving problems to make the simulators more and more useful, I think that exact same journey is going to happen on the ADAS side. And so mainly what I'm going to take you through in this presentation is sort of 6 trends that I see in the market, which I think are really going to be driving this greater ADAS usage of simulators. I retired last December, and then I went and set up my own consulting company. I've been doing ADAS consulting since December. That's the part there. Causality LLC is my consulting company. And then a month and a half ago, I accepted a job as the research director for Mcity, which is an engineering lab in the College of Engineering at University of Michigan. So these are the 6 trends that I'm going to take you through. I'm not going to read them on this slide because we're going to go through them one by one. The first one there has to do, actually the first 2 really have to do with this idea of software-defined vehicles. So let's talk about that first. That's a major change that is coming to the auto industry. It's really effectively the simplest analogy is that it's taking that sort of smartphone business model and bringing it to the automotive space, where you have a hardware platform that's sort of the analog of the smartphone handset, and then the content that comes to the customers in order to keep their experience fresh is really software content more than hardware content, especially in the ADAS space. So you'll have customers paying subscription models and being delivered new content over the air to update their features. And that sort of app store, app model of delivery of features, it works great on smartphones, but there's an issue within ADAS, which is that a lot of our features are safety critical, right? So when the features don't work, it can be significant. The hazards are significant hazards. And so this is really going to drive a lot more test need and then the need for more efficiency in DV work. So the first trend is this increased demand for feature freshness. If customers are paying subscriptions, you got to give them a reason to keep paying the subscription, right? There's going to be an expectation that the features will remain fresh and will get continuously updated. That demand for feature freshness is going to put us on a much more rapid software development cycle. So there'll be more iterations of the software on more iterations of the platforms, which will drive considerably more development and verification work. In addition, if you can think of like a feature updates and then a customer has to interact with that feature, you'd really like that interface to be very intuitive. People don't want to read manuals. They don't want to, figure out instructions. I'll be honest, ADAS features do confuse a lot of people in vehicles these days. There are a lot of people that I can't figure out how to make that work, so I don't use it. That's a real problem with an ADAS, and it'll be a bigger problem as we start iterating features more quickly. And so testing those human-machine interfaces and testing the intuitiveness of the designs is something that I think simulators are really, really great at. Trend 2 is the fact that if we're giving the freshness to the vehicle through software, we're not doing it through hardware. We'd like to try and increase the longevity of the hardware platforms so that you have the same platform, you're just delivering new software content as time goes on. But the issue with that is that at job one of that platform, you got to make sure that there's enough capability in the platform so that it can last for years and years of feature updates. So you got to think ahead of all those features you might deliver through the life cycle of that vehicle, and what kind of hardware content might they need, and what might that drive into the initial hardware launch. So like, for instance, if somewhere down the road you needed steer-by-wire for one of your feature updates, then you might have to think about that, pulling that ahead. But those are kind of difficult decisions because they involve cost, and maybe cost that doesn't get monetized initially. And so you really need to have those upfront discussions to gain alignment on the plan. And the simulators are a really great place to show what a feature can do before it actually physically exists, where it exists only, say, in the simulation world. Trend 3 is the adoption of AI. This has been, really sort of a magical journey to watch, really, because, for years we hand-coded C++ algorithms. That's the way we defined all our algorithms, right? We would come up with these really ingenious algorithms, hand-code them, run them on the vehicle. And what we found is that with the advent of AI, basically AI is taking over all of those hand-coded algorithms and replacing them. And the reason it's doing that is because the AI algorithms consistently outperform the human-coded C++ algos. And in fact, they surprise us a lot of times in new sort of emergent behaviors where we go, wow, that works a lot better than what we expected it to. But there's a significant issue, which is that when AI algorithms fail, they often fail in ways that are really surprising to us. Like on the upside, we say, I didn't expect it to do that well, but there's also times when you say, I didn't expect it to fail that way. And the difficulty is AI algorithms are not human readable, right? It's a set of optimization weights. So you can't read through the code like we do with C++ code. So, when things fail, you can't just go look at the code and say, here's why it failed. The way to interact with the code is through testing. You have to test it. And that additional testing is obviously going to drive a lot more development work, and anything like simulators that allow us to do that development more efficiently will be sorely needed as we move to this greater adoption of AI algorithms. Trend 4 is around the advent of level 3 features. So a level 3 feature is a feature where we tell the driver, okay, the conditions are right, so you can take your feet off the pedals, you can take your hands off the steering wheel, and you can actually take your eyes off the road. It's okay to watch a movie now because the vehicle will drive itself, but we tell the driver you have to remain re-engageable. So if the system asks you to take over, you need to be able to re-engage. If you just think through the human factors challenges of that, you can see they're really daunting, right? Like, we tell somebody they can take some time off, but they have to remain re-engageable. How do we monitor that? How do we make sure that they remain re-engageable, in fact, and that they haven't zoned out and are potentially on the way to falling asleep? Also, when we need to re-engage them, and this is the example I'll take you through, say there is some sort of imminent hazard that pops up. How do we re-engage the driver usefully in that process? So this video that I'll show you here, this came from a talk that Waymo did. Waymo has a level 4, a fully autonomous vehicle, but evidently in one of their drives, what happened was there's a barbecue grill on the back of the pickup truck that's on the left of that screen, and it's going to fall off of the back of the pickup truck right into the path of the AV. And so think about this in terms of the challenge of, we've told the driver you can watch a movie, you can take your eyes off the road, and then this happens.
What you see here is, as soon as the pickup truck at 64 miles an hour, a barbecue falls out and goes straight in the path.
So now we have a situation where the driver's potentially watching a movie. We can't re-engage them in time to handle steering around that barbecue grill. So we'll probably need to start the evasive lane change. but we should also tell the driver, hey, driver, we need you to re-engage, right? So how do you do that? How do you do that well in a human factors context? And how do you do it well so that it works for members of the general public, not just trained engineers, right? And so I just can't see any way you could do these kind of experiments safely with the general public without using simulators, right? I mean, even with trained engineers, I wouldn't do that on public roads, right? But certainly not with members of the public where we say, here's how our feature is going to handle this situation. How do you feel about this as a customer, right? So this is critical design work that needs to be done in a simulator. And so I think this one's a really compelling one for a use case that really can't be replicated outside of simulators. Trend 5 is about cost pressure. So as long as I was in the auto industry, there were cost targets, cost reductions every single year, right? It is a fact of the industry. It will always be a fact of the industry. And as people look to lower costs, they look for the big targets, right? And right now, we got to admit that ADAS prototype fleets are a big target. A lot of the work is still done by flashing features onto vehicles and driving them on public roads on these long real-world test drives, which are potentially a team of engineers driving across the country and back, right? So very expensive prototypes that are used in very expensive tests. And so anytime there's a cost reduction target, that sticks out, right? And so there will be significant cost pressure that's brought to bear in that area. And the final trend is one, that we saw actually in vehicle dynamics. In the beginning in vehicle dynamics, I remember we had this ambition. We were like, we're going to figure out objective metrics for everything, right? And we thought we could, and we tried, and we found out we can't. Some things are just subjective. We know how to rate them as humans subjectively, but we have trouble finding metrics. It's even harder. The challenge is even harder in the ADAS space. Because when we drive vehicles, we talk about things like, does the feature feel trustworthy? Does it feel decisive? Does it feel like it's behaving with confidence? It's these kind of judgments that we're making about the features while we drive them. And so, the realism of that is just that it's very hard to figure out how to objectively quantify those. So when you have a situation where you have simulation models that you want to subjectively evaluate, how do you do that, right? That's simulators. That's the use case for simulators. And not only is it a good development tool, but it's also very helpful for management, right? Today, I'll be honest, most drives, it's managers saying, put the feature in a physical vehicle, flash the feature in, and let's go drive it. But I think, our ambition in this space should be for management to say, put the feature into the simulator and let's go drive it in the simulator. I also see that simulators are a really nice place for simulation engineers and development engineers to find common ground, right? The simulation engineer knows the details of their model, but they don't know how it should feel. The development engineers know how vehicles feel, but they don't know all the details of the design. So getting those two together in the same simulator so that the development engineers can subjectively evaluate the CAE modeler's model, and the CAE modeler can hear the things that the development engineer is evaluating and get alignment on where they agree, where updates are needed, what the plan forward is. That's another really great use for simulators. So those are the 6 trends that I was going to take you through. The demand for freshness, that's going to drive more software content, more software updates, which is going to drive more development work. The demand to lock down hardware platforms early and not change them over time, meaning you have to have a lot of alignment discussions up front about what content goes into vehicles at job one. The fact that AI is taking over from C++ algorithms, and AI is not deterministic, it is not human readable. You need to test it. And level 3 is coming. There's an enormous amount of work happening on it, but human factors is a real significant challenge at level 3. Much more so at level 2, the driver is fully responsible for safe operation in the vehicle. And at level 4, the vehicle is fully responsible for a safe operation of the vehicle. But at level 3, we have this shared control paradigm. The fact that cost reductions will be ongoing, and the fact that ADAS is even more subjective in terms of its evaluations than vehicle dynamics is, and probably will remain so. And so simulators are a really great way to allow people to subjectively evaluate simulation models. So that's what I had. Thanks for listening.
All right. Thank you very much, Greg. We got an opportunity for one question for Greg here before we go. I mean, the ADAS space, I know some people out there asking me questions about it. Anything for Greg here before we go on? Greg, when we talk about ADAS, ADAS doesn't exist in just its own sort of vacuum, right? ADAS is part of the larger vehicle development process. Would you say that human factors, or HMI, or vehicle dynamics are more important to ADAS development, in connection with ADAS development? Sorry.
Yeah, I think one of the big challenges is that in order to get an ADAS model to work in a simulator, you first have to get the vehicle dynamics model to work. Then you got to figure out how to model all the sensors, and then you got to figure out how to get the feature to run. And so it's a much more intensive task to get it to run. So vehicle dynamics is like the foundation. It has to be there. But areas we're going to need some real progress in is the realism of the sensor models, because that's critical within ADAS. You know, when a radar sees a ghost target and reacts to it, we need to see that in the simulator as well, right? And, you know, that's just going to be a challenge, right? The greater workload of get the vehicle dynamics model to run in correlated, get the sensor models to run in correlated, get the feature loaded and running. That's more steps than it takes to do vehicle dynamics development work. So that means that when somebody says, let's put this model into the simulator and go evaluate it, it takes more time right now. And that level of sort of friction in the process is something we need to work on to remove.
Thank you, ladies and gentlemen. Greg Stevens.